we're talking about today is deployment and containers and a specific case study on us, Collective Health. So just kind of a prelude to the madness to come. When we talk about deploying Go, really what you're talking about is you just build it. If you're on a Linux machine, you just build it with Go, and assuming you're deploying to a Linux machine in the cloud somewhere. If you're on a Mac, you can use the cross compiler. The command, the different environment variables that will cross compile for you, or the very convenient GOX and GoXC tools that also do cross compiling, depending on how you want to do it. Sagar, I think that we're gonna have to need help getting more chairs for everybody. But after you build it, you just got this binary, and all you do is copy it to the server in any way, shape, or form. Usually SCP, FTP if you're feeling barbaric for whatever reason. And after that, you just launch it. You can run it manually, but normally you're going to use like an upstart or a systemd or a supervisor D to kind of launch it, and then optionally you just monitor. It's basically as simple as you can get. Right? This step here is the part that's very, very simple. You don't need package manager or anything like that. You just copy it and run it. It's very, very trivial. This is the reason we do that is because Go creates static, self-contained binaries, and it's kind of magical in that sense. It used to be every program was like that back when people did things in C, but anything you write in Python or Ruby or Java is not that. If you have a jar file, you need Java runtime and all that other stuff. So this to me is a little bit magical and just kind of one of those things that.
So it's kind of ironic. Those standalone binaries.
Yeah, I know, right? It's kind of how everything used to be that way, but not anymore. But anyways, this is not what we're going to talk about today, just because this is obvious and easy. We're going to get into a little more into the wild side. So first, a brief interlude on the nature and notion of deployment. What it is. Normally, when you think of deployment, right? There's this kind of typical flow. If you start off on your local machine, coding or developing of some kind, you push it to like a dev environment or a test environment, then a staging, and then a production. And you kind of want to ask the question, where does deployment begin? Where does it happen? What is deployment? And most of the time, people talk about deployment as, oh, that's when things get to prod, right? When I think of, conceptually what deployment is, it's not really over there. It's way the heck over here, right? Really, every commit, when I think of just modern, ideal deployment, every commit that a developer checks into Git or whatever version control you're using should create a potentially deployable artifact. Just in the sense that when I commit something, you should be able to build something that, whether it's a Go binary or a jar file, with the Java runtime or an entire container, it should be something that I can, use to get to production at some point. And I say production in the sense that you got to go through the testing and the staging and all that, but eventually it should be able to get there, right? Like you don't want to have to mutate the thing that you're checking in here as it moves through the pipeline, especially not, you don't want to mutate it excessively, if that makes sense. And I think it was the Incredible Hulk who said every commit is deployable. But don't quote me on that. I'm a little fuzzy on the details. Which brings us to containers, right? A lot of you are here because of, I don't know, buzzwords like containers or Docker or Rocket or whatever. The CoreOS, things like that. It's certainly not for me, because when I'm the only one talking, we get like 3 people showing up. So I'm certainly glad to have the crowd. I want to thank Eugene for pinch hitting for us afterwards. Our guest speaker coming up. I blame him for us being able to order large amounts of food for all of us. And by blame, I mean I thank him profusely. But anyways, containers, why we're here. Basically, containers get us closer to our ideal concept of every commit is deployable. Not deplorable. When I commit things, it's deplorable. On the whole, when our engineers commit, we want those to be deployable. The idea, the reason we have containers, the reason why they've made so much noise in the industry is that you're packaging the context and the actors into a single artifact, right? And when I say artifact, I mean just one thing, right? It's not like, it's not like an RPM package or anything like that. It's basically one thing that you can move around and just run and execute in order to get the output of what you want. And just this notion of having everything kind of packaged at once, the config and the environment and the runtimes into a single artifact is very, very powerful. and combined with a proper build system, it again gets us closer to the ideal of what we're looking for. Let's see. The thing about containers is they're new, and it's a little bit of a wild west, and we're learning a lot of new things. We're learning some things we've learned 30 years ago but have forgotten. Kind of like how ironic that certain things are magical again. It can get a little bit inception-y, when you have laptops running VMs, running containers that might potentially have containers inside of them, things like that. So you guys all seen the movie? The movie has nothing to do with talk, but it's just a convenient word. Russian nesting doll, same kind of thing. Everyone gets the inception. Some of the things that we've learned, you want to automate everything. That means scripts usually. Whether it's Python or Shell or Ansible or whatever your poison. Pick your poison. We use Docker. I personally really like Docker files. I think they're a really solid solution to what we do. Docker is progressing very fast. It's not ideal, and there's a couple of alternatives at this point. Before Docker, people would roll their own container solutions. Rocket is another one that's kind of up and coming. It's still, I don't want to call it early days, but it seems to be progressing well. We also really like the CoreOS tool set. The set of tools. The CoreOS philosophy in general. So aside from the company's point of view, my belief, my philosophies of how you do modern DevOps aligns very closely with the way CoreOS thinks about things, and that's just kind of like minds think alike, or they're very genius minds, and I'm just lucky, or even a stop clock is right twice a day. There's a question in the back.
Yeah, what do you guys use for automation? I know you mentioned a lot. I'm just curious what you use.
We'll get to that. The quick answer is we use Ansible to quickly set up kind of like base machines, and then a lot of our automation is done through just through Docker and the way we build Docker containers and things like that. So hopefully it's complicated because there's not a one sentence answer. It's kind of like our entire system is based to some degree on not needing a whole lot of automation, if that makes sense. But anyways, yeah, we really like tools like etcd and Fragility and things like that. Like I just mentioned, we use Ansible rather than Chef or Puppet just because it's a better fit for what we do. But most of the config that you would use a Chef or a Puppet for happens inside the Docker container via Docker files. So it mitigates the need for a really robust change management system. Basic container strategy. This should be no surprise to anyone. At a very high level, you run a set of containers in a VM on your Mac, or if you're on a Linux box, just on your laptop or whatever. And then you take those same containers, and with slightly different config, maybe different IP addresses or different domain names pointing to servers or whatever, you can run those on beefy cloud VMs, right? So we talk about running the same thing in different environments. The reason why I got interested in Docker in the early days, the 0.5 days or whatever, is that it got me closer to this, where local development and production are almost identical. If you ever try to do Postgres work where the cloud Postgres and you're running like Postgres locally on your Mac, it can get be a little nightmarish, and you get a lot of works on my machine, but not in dev or production or things like that. And that's what we're trying to avoid here. This is why containers are cool, right? We're trying to get rid of works on my machine problems. Containers have a lot of issues, right? They're config issues. How do you do that? It seems nice that you can have different configs at different stages, but there's quite a bit of complexity. I've got an entire section of the slide deck dedicated to config complexity. Keeping containers up to date is kind of a pain in the ass. They tend to age poorly, especially if you're doing things like it's running entire Ubuntu distributions on it. Ubuntu is kind of one of those platforms where you need a bunch of you got to keep the updates things going. So keeping them up to date has always been a problem. You got to be prepared. Your entire system, your build system, has to be able to rebuild things from scratch easily and often, and preferably automated out of your hair. We use Jenkins and .ci, but we'll get into more detail on that to do that for us. Containers can't normally see each other. It's like a security feature, but it's also a pain in the ass feature, right? Sometimes if you're behind a VPC, you can just say, fuck it, I don't care if they, I do want to open them up. This leads to things like IP overlay networks, like Flannel-D or similar, where basically all of a sudden they can see each other because you're doing some magic with network stuff, network magic stuff. There is you know, in small scale deployments, you know, you start off typically using port forwarding. This is very, very fragile. It doesn't scale very well. So the IP overlay, even though it sounds scary and like you're doing some magical stuff with you know, giving a container, you know, multiple IP addresses and things like that on different subnets, but relying on port forwarding is very fragile, and I don't recommend it for anything but, you know, the smallest of projects. How are you doing on chairs? There's a couple chairs in here. Don't feel like you have to stand up.
Alright, just leave my name tag on the seat.
Get a beer on your way in. There's some right in the bucket behind them. Yeah, over there. Where you store your containers is one of those choices you have to make. You know, there's hub.docker.com, you know, which is kind of the classical place. You can, you know, it's slow, it's not free for private, you know, it's free for public things and paid for private things. The slow part just comes because it's a big multi-tenant thing where, you know, the Java containers in particular can be large, you know, gigabytes. If you're going to run your own private repo, you know, that's also an option. You can there are solutions in between where you pay a third party to host a repo for you, which kind of takes the operational overhead off of you, but you know, it doesn't solve some of the issues. Sometimes speed and you still have the speed. You occasionally have the speed issues. We're doing this just because I think we got tired of hub downtime. And hub speeds, you know, we're here when we host this on our own machine on Amazon Cloud. We ended up getting about 10x improvement in actual throughput, just because it's basically dedicated to us in the office for whatever that's worth. So, we actually use, again, almost coincidentally, a product called Enterprise Registry, which was formerly known as Quay.io, which was acquired by CoreOS for whatever that's worth. So, we like it. Container issues. Continuous integration is a challenge. Not all CI systems are Docker aware. The ones that are kind of expect you to play by their rules. You know, it's like one container per repo or things like that. You know, it's not ideal. I think the pace of container technology has progressed beyond what the CI vendors and the open source solutions have done. But it's not terrible. You can kind of make it work, but you're helping, you know, you're either writing a ton of helper scripts or you are, you know, playing nicely with their, you know, their worldview and their implementations, things like that. So a couple different trade-offs there. Briefly mentioned earlier, and kind of relates to the automation question, we use Jenkins with the .ci plugin from Groupon, and that gets us pretty close to what we want. And again, the .ci in particular has a one container per repo kind of implementation, so you're going to have a lot of little repos if you've got a very heterogeneous network. Heterogeneous set of components. Deployment, you know, the promise is that containers run anywhere. Here, really, the reality is that fragility is normal, and that you're constantly engineering around that. You know, you're engineering against fragility. Like your scripts become more and more robust as you find out what the weak points were and the potential points of breakage. You know, it works for your first 3 employees, but a fourth employee with a brand new Mac, all of a sudden, wait, why is it not working? And there's some edge case that you haven't thought of. You know, maybe because I don't know, their username is too long, or who knows, right? It could be anything. You never really know. Get into a case study here. I'm going to drink my beer, so give me just a moment. I'm talking quite fast, so I apologize for those of you who can't understand me. I always talk fast, but tonight in particular, I want to make some time for our beloved guest speaker. All right, so talking about collective help. You know, we made a lot of decisions in the beginning. Some of them didn't work out so well. Some of them did, and I hope to share more of the things that did work out. One thing we did is we enforced a common directory layout against all of our employees, and this worked out really well. Everyone's got a root dir that we call chroot. It stands for collective help root. Just in case it wasn't
Not
obvious.
confusing at all.
Yeah, no. People are like, what the hell? Yeah. You know, GoPath, of course, you know, if anyone here is a Go developer, everyone's already got a GoPath. But even our GoPath is the same when we put it inside of our chroot. Basically, just having this root path means that, and especially defining it as an environment variable, means that we can, you know, that we can write scripts. You know, this is part of engineering against fragility. Doing it this way means that all of our engineering, we have an expected directory layout, and this is the part where convention helps. You know, engineering conventions mean that, you know, you can write scripts that are a little more robust, things like that. The way we do it is at the root, we've got a bin directory, we've got a bunch of like repos, and then of course inside our Go path, buried in our GitHub account is all of our Go-based repos, because Go is a little specific about how it wants its directory layout to be. So usually repo 1 and 2 will be like documentation projects or Java projects, things like that. The repos buried in the Go path are Go projects. Make sense so far?
Yeah, just with that. So if you look at those different repos, right?
Right.
And when you look at, have you got sort of like different functionality in each? So when you deploy, you're deploying sort of like 4 code bases using this, or is it all just sort of the one code base?
We'll get to that.
Yeah.
The answer is depends on what time scale you're talking about. We've evolved over time for that.
So right now you do. Ish. We'll get to that.
One of those repos at the CH root level is called devenv, and this is basically a shared repo of scripts and metadata and documentation, and for a while we put a lot of config in there, but I'm going to revisit that, things like that. Basically, this here is when we get a brand new employee, we come in and say, check out devenv, go through the readmes and the documentation in there, and by the end of the first 3 readmes, you should be having a working building cluster on your laptop, things like that. So having one repo with all the documentation and stuff, I prefer this to a wiki. You can track changes here. Everyone knows the state of this, things like that. Having the scripts and the documentation and some of all that stuff kind of centrally located just makes it a pretty strong win for us. I don't know if this is going to scale to hundreds and hundreds of employees, but where we are, I think it'd be fine through, call it double-digit employees. Triple digits is where I get a little worried. All right, next slide is a mistake. So our DevOps lead kindly corrected me that our devenv is actually more like staging, where we have 3 VMs. But let me start from the beginning. So basically, we have on your local machine is a laptop. That's what this square outline is. And then the gray square is a Linux VM, and then the red circles are containers, right? So our cluster is represented by a whole bunch of these Docker containers. In development, all these here are in the cloud, right? So we've got different, in our own little Amazon VPC, we've got a bunch of different environments. Our dev is actually 3 boxes laid out like this, so this is actually wrong and outdated. I think it used to be this a long time ago, but we have switched to this. Excuse me. For dev, we use tiny, wimpy, cheap boxes. For staging and production, we use big, beefy boxes. The configuration of the staging and production machines are exactly the same. And production has real production load. Staging has basically no load. But we do configure them exactly the same. We expect things like memory and disk and all that stuff. Make sense? We'll come back to that picture, especially a little bit to kind of what we plan to do in the future. Config is a pain in the butt with respect to Docker containers. I had talked about how these are the exact same containers and you inject different kinds of config. I'm going to dig deep into that because that's quite an easy statement from a high-level, 30,000 foot, back of the napkin, whatever cliche you want. When you dig into the details, there is a lot of learnings. So you need to be able to, I call it inject, but it's not always injection. But you need to be able to somehow edit or modify or insert config into the containers. You need to be able to keep track of per container configs, which config files goes in which stage they are, if it's production, things like that. And you also have to take special care with secrets, tokens or passwords, things like that. You don't want to check these into GitHub. Most of the time, if you're just doing IP addresses or domain names or config flags, it doesn't matter if when you check them into your repos or whatever. But obviously, passwords and tokens, you don't want that inside your version control. So how we do it is currently. We'll go back to how we used to do it after this, but currently what we do is every repo, every Go project that creates a server, or every Java project that creates a component in the SOA, every repo has this container directory at the root level of the repo. And inside it's got the Docker file, and it's got setup scripts, and it's got config for different stages, dev config, staging config, production config, things like that. It's supervisor if that particular container needs it, things like that. So all the config is isolated in the actual container there. Basically, the build system, Jenkins and whatnot, can use the Docker file and use these scripts to build an entire container using nothing more than the metadata contained in the container directory. This is a direct result of how we talked earlier about how continuous integration systems don't always play nice, and they kind of expect one container per repo. This is the end result of that. So this is us to some degree playing nicely with the continuous integration systems. The other thing we found is doing it other ways. It just makes us we can lock down a lot of this config stuff in version control, which helps quite a bit in the long run. Being able to see how the config mutates over time, helps us track changes, and especially when things break, we can go back and do other things as well. We used to do it where we had kind of this master super config repo where all of the config was located in here. So the repo 1 and the repo 2 were just source, but we would store those, config.prods and those supervisor.confs and stuff, and in an actual config repo, a dedicated config repo. The advantage to that was you had a very, very strong sense of what the state of the entire cluster was, the SOA itself. But there were a lot of disadvantages because all of a sudden your source and your config is divorced, and especially if you're updating kind of what kind of config you expect, and you got to basically keep two repos in sync, and that becomes a little bit of a nightmare. So we kind of went back to keeping the config co-located with the source and then separated out for whatever that's worth. You want to minimize the amount of work needed to customize a container. Basically, what we're getting at there is each container at different stages. Over time, you're gonna have a lot of different things that need to be separately configured for each one, right? Things like what your DNS is, and where the relevant servers are, what the domain names. Is this guy talking? Is this supposed to be talking to a prod database or a staging database or a test database? Things like that. What you want to do is engineer it so that you basically, with as little effort as possible, on behalf of your scripts or your apps, are able to get out the more recent version, or get at the correct config you need to. Our containers, at a very high level conceptually, they contain config files for every environment. When we ship a container, remember how we said one container everywhere? Basically, what we do is we put in, let's see if I have an example of this here. We put in every container on the actual file system of the container somewhere. It contains config.local, config.dev, config.staging. So it contains all of these. And again, we should keep the secrets out of these. We'll get to the passwords and the tokens later. But for all the harmless data, we basically ship the container with everything. And then what we do is when we run, do a Docker run, we just tell it, this is staging or this is prod. So basically, with one flag here, we can set up, a vast number of variables and other stuff inside the actual container itself. So that's kind of what I'm talking about there. There are a lot of options for getting config in there. We currently use a lot of config files, and that's fine for certain kind of data. Other options are just injecting different environment variables or key value, using a key value store where you have you populate the key value store, you seed it with the correct data for whatever that environment is. You want to make sure you're using the same method for all. Like if you are using environment variables to configure local dev, but you're using a key value store for prod, that's a smell. That's a code, DevOps smell that you want to address at some point. So make sure the way you configure local is the same way you configure prod and all the stages in between. Again, we're using flat files now. It works for the most part. If we're having scripts inside the container that need to be run, we can use this cluster M environment variable. It's kind of like a high level one set thing, and that'll load the correct flat file that we need. If you inside an app like a Go app or a Java app, you just have the app itself query, oh, am I on production or staging? And then you can either do things differently or load the correct files appropriate for that environment. Make sense? Secrets. So just one slide here, tokens, passwords, etc. Definitely don't check these into Git, especially if you're using GitHub, even if they're private repos. Even if you host your own Git, don't check these into Git. It's not guaranteed that even private repos are always going to be private or always going to be self-hosted. So what you really want to do, what we do is we have just a few, basically one, a set of flat files with the secret in it, and we keep them, locked down tight in our secure storage, shared area, just for our engineers. When you do update the file, we just use Slack or email, right? The size of our team, again, it's fine. It probably is not going to scale to triple-digit developers, but for where we are today, this is fine. Long term, right? There's a lot of options for you. You know, HashiCorp and Square just released 2 products in the past couple of months. You know, I think one is called Vault and the other is called KeyWiz, and these are both designed with a lot of security requirements in mind to actually solve this problem of how do I share secrets without actually, you know, while being, you know, while doing the right thing with respect to keeping them secret. Amazon's, you know, KSM is another solution. We don't use these products yet. We probably will at some point. We do plan on using an HSM to store our master keys, and that's just an actual hardware security module that you can install in Amazon. We pay Amazon to install it, or they install it for us, or how does that work? Yeah, both. So we pay Amazon to install it, and they actually install an entire hardware module for us that does the magic, you know, master key holding record, you know, not sharing thing. Yeah. That's all I have to say on that. Make sense? Any questions here? All right, good. I don't know as much about that as I can. So local development was something we focused on a lot. You know, this is all great if you know, we're talking about how you want your local development to match production very, very closely, but if it slows down production, I mean, if it slows down development, if developers have a 20-minute, a 30-minute build cycle or to build up these containers, then something's gone terribly wrong, and it's not worth the trade-offs at that point. We wanted local development to be easy to do. You know, it should be simple as running a file, you know, and you know, running a script that's essentially a compile phase or a build phase, and preferably that script goes by very, very quickly, and then have them test the local cluster on their machine against that, things like that, whether it's hitting an endpoint or checking some, you know, front-end feature or doing some, you know, checking some logout. It almost doesn't matter. But this loop, the edit, build, and test loop has to be very, very quick. So that's kind of what we're talking about there. And if we don't do this, then that means the cost that we've paid to do all the other nice things, like every commit is deployable, it's not worth it for us at that point. At Collective Health, what we currently do is we talk about where we spin up a single VM with 5 to 18 containers. The containers are things, all of our front-end code, you know, that have that are being served by Nginx. That's kind of like our front-end box, our front-end container. We got many, many back-end components. Our back-end is very heterogeneous. You know, we've got, you know, business logic areas, you know, the PDF generation boxes, and you know, classic microservices, stuff like that. We got a JSON endpoint box, things like that. We have a messaging layer so that all the boxes can talk to each other. And of course, we've got DB and NoSQL containers. I do want to talk about the database, right? And this is kind of one of those exceptions. You know, in local development and dev, we use DB containers. In production, we're more likely to use something like RDS or a dedicated DB machine. So this one here is a little bit of an exception to kind of what we're talking about when we say production and local are the same. It turns out that one exception is totally fine. We haven't really run into, you know, any significant issues with that disparity. It takes one script for us to spin up a well-configured VM, and then one more script to basically build and run all the containers. So it's a 2-script solution. The only reason we broke it up because you very rarely spin up a VM, but you're building and running all the containers all the time. We're constantly blowing away containers and starting from scratch. All data, especially on local, we consider basically ephemeral. You know, we don't expect to keep it. We just throw it away. You know, if there's data we want to progress between runs, you know, we'll automate it into like a tester or a setup or some kind of thing. So basically, the entire dev system itself, the dev environment the local environment is considered disposable. And again, this is something we do often. We want to be able to quickly blow away and start from scratch for all intents and purposes.
What do you use for your scripts?
Bash, maybe Python, usually Bash. We tried a bunch of different ways of doing this correctly to kind of get the goals. One of the first things we started is we'll spin up the containers, and we got a nice environment humming along. We have our developers edit the source code, run a script that builds and cross compiles and injects that binary into the container. Basically, it kills the running. If it's a JSON API, REST API server, right? It'll kill the server, inject the new JSON API in there, and then spin that and start that one up. And one script that does all that stuff: the build, the inject, the kill, and the start. And then, of course, they can test. Now we can hit that endpoint, with whatever front end or whatever JSON tool we can. This was good, but it was a little bit fragile, and it was hard to replicate against different boxes, and it didn't work as well for things like Java components. You've got a large, when Maven kind of expects to really control everything, how that works. The one thing that's been super helpful to us, that all of our scripts are, again, in that one big shared dev env repo, that has all the metadata and documentation of all that. The thing that really helped us was, we talked about how Russian doll and Inception-y, using these VMs and these Docker containers can get. We bust out of that a little bit, and we kind of break the metaphor somehow. What we do is we mount our users directory into the VM, right? And because it's a local VM, it's totally fine. It doesn't actually matter. And then what we do from there is specific folders are mounted in the containers as volumes. This took us almost a year to get here, just different trial and error. But what that really does, though, is that allows the containers, not so much that you don't have to inject things in the containers, but basically the container is running off a local directory, so that anything you do, when it is a rebuild and stuff, you don't have this inject phase. It's already in there, if that makes sense. So that is kind of one of those things that we came across that is so far working out really well for us. Which brings us to what we're currently doing. So what we do is basically we fetch the latest containers from our continuous integration system. Right? We mount the local volume with all the pre-built binaries, like our JSON server or PDF processor and our business logic component. So each container, like the JSON container, we mount the directory that has the JSON binary and the JSON config in it. And then we can run that, right? So that way, when we run and we rebuild the JSON binary, it's already in there, and all we got to do is have the container just kill and restart that one process and that one file, and that actually works really well. You're only overwriting the local binary, and then you just restart the process from within the container via either you can use a Docker exec to get in there and toggle it, or use something like Supervisor D that has a convenient web interface.
You can also do Docker stop and Docker start.
Yeah, Docker stop, Docker start also works. It's basically the exact same thing. So there's a couple different options for actually restarting. Normally, again, if it's more than a simple line, you can script it as well. And then, of course, you can test your changes and whatnot. The dev patterns that we found that really works is that you want your continuous integration system to be building your containers. Every time you check in, and you made an edit to the Docker file, you can build it locally, but the continuous integration, your Jenkins or whatever, has to have a record of all the containers that you build for the most part. It does the testing and the shaming if necessary. You guys know about the email of shame, right? Yeah, when you break the build or your test pass. I get the email of shame all the time. Yeah, it's usually from my wife, but never mind. The front end, right? When you do it this way, basically what happens is that gives your developers a lot of flexibility on how they can use their local system, right? A front-end developer can point to dev, the actual cloud dev server. It can fetch all the Docker containers and layers that were built, that the CI has, and run those locally, basically getting tip of whatever the continuous integration system has built in the past. Or if they want to, they can edit the files and just build something locally that's not yet been checked in if they need to as well. So there's a lot of options. A backend developer is probably more likely to fetch whatever the latest is, and then make changes locally and either build their jar file or build their Go binary, and then those are now inside the container, and they can just restart and spin that up and run the new backend and things like that, and test against the whole cluster, even if they're just modifying one component. Does it make sense? Yes?
So each developer has its own dev environment in the cloud?
They can. We have one dev environment, but there's I think one of my goals eventually is to potentially have a mat dev in .collectivehealth.com or a Leah dev at collectivehealth.com or Bobby Froggy Pants at .collectivehealth.com. You can do it either way. I think right now most of the work we do is against local, the actual cluster running on your laptop, but there's no reason why you couldn't have one cloud environment per developer if you wanted to. At that point, it's a matter of cost and a little bit about the operational overhead on your DevOps team.
what's the purpose of the dev environment right now in your setup? Like compared
Which
to
one,
the
the
staging?
local one, or?
No, it's in the cloud.
Yeah, in the cloud, when we use
And
dev, you know, it's
To compare
rare.
it with the staging, it looks like it's the same, right? Like,
Yeah, the dev environment is just smaller and cheaper. For us, dev environment, you know, we use much cheaper VMs, right? Because I mean, they basically have test load, right, which is for all intents and purposes nothing relative to production load. But it's just one more stage in the pipeline. You know, a lot of our early QA is done on the dev environment. You know, so it you know also does double duty as a test environment as well. Things like that. So
The main difference also between dev and staging is all the commits that happen on Git, on master, it gets tested, built, and deployed by Jenkins directly to MyDev. So MyDev is kind of always a tip of Git, of individual components. So if something breaks or something happens, that's when you find out.
yeah, dev is like tip. Staging is more like release candidate, and of course prod is prod. What's up?
So the front end can point to any environment. I'm curious how you do that. Is there a name service that you have and you're pointing it, or somewhere there's a config file?
It's basically a flag in a config file. When they do a front end build, you know, with their Gulp or their Bower or whatever front end people do, they just tell, oh, for this one, I want to build a special one that points to.
So it happens at both times.
Yeah,
Okay.
yeah. They were looking at making it a little more dynamic, where you could manually tweak it, you know, choose which server you want to talk to. But that's just fancy. Let's get fancy. Yeah. I got no truck with the front end developers if they want to do that. There's a couple different ways to slice and dice that. All right. Build and release. So Parth, our DevOps lead in the back, raise your hand, Parth. Woohoo! We are in the business of shipping containers, is how he likes to put it. You know, fixing bugs and all that is great, but you know, it doesn't get to production if it's not in a shipping, if it's not in a container. So our entire flow is designed to facilitate the creation of containers, flexible containers as early as possible, especially containers that can be used in many different places. Again, we use Jenkins and the .ci plugin. We don't do continuous deployment yet. Possibly we will, but for us now, we just haven't. We do continuous integration up to a point, and then do, it's not beer, I kind of wish it was beer, but it's actually push button releases for staging and prog. Build and release begins, you know, early in the process. Like again, every commit, you know, becomes a potentially deployable container for us. So at any point, any container can be something we could eventually promote to production if we wanted to. Currently, we're doing whole cluster deploys. You know, we can tolerate the downtime. For us, it's just a couple of minutes. Eventually, we want to get load balanced and per component deploys. Just kind of what that looks like here is this whole cluster. Of course, you've got your version 1. You take everything down and you spin up version 2. Right? You might have in our case, it's a few minutes of downtime. We tolerate that now. We're not going to tolerate that forever, but in year 1 of our, you know, of where we are today, I think we're fine with it. Load balance per component is kind of what you expect it to be. You know, we have, you know, we got your version 1, you know, for say, you know, the PDF generation, PDF processor component. We'll spin up both. All new connections go to the blue one. We wait until the red one drains and finishes the work it's currently doing. When there are no active connections on red, we just turn it off, and all of a sudden we got a brand new PDF processor in place without having disrupted any of our users or members or the cluster on a whole. So this is where we're going. We're not quite here yet. We need to fix up our messaging infrastructure a little bit before we can get here. Any questions so far?
What's your messaging backend?
Something we wrote in-house called Tessel, and we're currently rewriting it. So the version 1 of Tessel is call it a prototype. So we're hardening it, and we plan to open source that as well. I mean, technically it's already open source, but it's garbage right now. You can look at the repo, but there's nothing good there. Wait till one of my guys rewrites it for me. I wrote version 1, so that's why I call it garbage, for whatever that's worth. Version 2 is coming out in a month or two, and I'm really excited. I've been doing a lot of code reviews on that, so I'm really excited about where Tesla's going. And we'll probably have a whole talk on our messaging infrastructure at some point. You know, that's an entire hour at least on in and of itself. So just a little teaser there.
How much are you going to worry about version differences in APIs between them?
A lot and not at all. So basically, we just kind of do the right things, right? If there are components in the cluster that speak version 1 of an API, right? You know, I got to make sure, you know, if the blue is a new version 2 API, you know, the blue thing should either support version 1 and 2 simultaneously until all the others get blued, or you know, you make all the guys talk to, you know, you make all the things, you know, talk version 2. You know, you basically just deprecate intelligently for the most part, if that makes sense. We're doing it manually now. Eventually, we'll have fancy service discovery and whatnot, but that's later on down the line. But deprecate intelligently, and we found it works. You know, again, for our size, we take a few shortcuts there. If you're Google size, you know, they have an entire service introspection infrastructure for the very, very, very large companies. Make sense?
So what do you do now to not disrupt traffic?
So it's not on this, but you can imagine a load balancer right here on top of the component. So stuff is coming in, right? When we spin up the blue, what the load balancer is going to do is say, oh, I'm going to send 10% of the traffic to the blue, just to make sure blue is totally not broken, like a smoke test. And once we stare the metrics on blue, okay, it's not broken for like 5-10 minutes or whatever, then we'll route all the new traffic to blue. And then the red traffic, the red sticks around until it's returned all its values to whatever clients it's talking to, whether that's external outside of the cluster or internal responses inside the cluster. Does that make sense? So the load balancer that you can't see is up here, you know, kind of in front that helps from disrupting traffic, if that makes sense. And again, on the whole cluster version, we just throw up the maintenance page. Yeah. Sorry, dudes. Yeah. Come back in 10 minutes. Yeah. Make sense? Artifact promotion. So when we say artifacts, we're basically talking about containers. The way it works for us is that continuous integration does the initial build and promotes it to the dev environment, and then after that we use operations. This is our V1. So this is what we're doing now, and it's definitely not going to be like this forever. But as of today, basically whenever a local developer checks in a commit, it builds. The continuous integration sees that, it runs tests, it builds the container, and populates the container in our repo, our Docker repo. From there, it also then injects it into dev, where it needs to go, and brings the container up over there. Right? Our testing group, you know, the automated test, and in some rare cases, manual testers will have at it then. They'll promote the containers to staging. And at that point, ops is responsible for pushing it to prod on the appropriate schedule, you know, after chatting with the appropriate business units like sales or marketing or customer service, things like that. Make sense? So again, these are what we call push button releases. They're basically manual, copy things over and spin things up. This here is through continuous integration. The goal, of course, is to get more configuration in these intermediate phases and more automation.
Your test engineers are working where right now?
Some of those decks in the back.
Okay, thanks. Do they use one of these environments as well?
All of our test engineers are able to, you know, they can log in here, or they can run it on their own if they want to, you know, if they're writing, you know. Basically, all of our developers are expected to write unit tests for the modules they write. Our software test engineers are usually at the cluster level, end-to-end, or systems level testing, right? So they'll write, sometimes it's like unit test style, but except against the whole cluster. Sometimes they're writing entire components for the whole purpose of stressing and testing out different paths through the system. Right? And they can do that at any stage. Like they could potentially have their own little container that is nothing but, you know, pinging and poking at the cluster on the whole.
And the reason I asked is, like, similar to what you're saying, usually our devs basically do the unit testing. We give it to our QA guys in the QA environment, which in this landscape looks to me like staging, and that's where you do your integrated testing, but you may be using dev, and that's what I was trying to clarify.
So the arrow means that the test engineers have promoted it from dev to staging. So a lot of the early automated testing and manual testing is done here.
Okay.
There's also stuff done here, but by this time it's considered pretty, you know, it's basically release candidate at this point for us.
Okay.
That makes sense. Does that answer your question?
Yeah, it does.
Yeah. Sorry for the sarcasm.
That's okay. That's good.
Yeah. I do want to get into a bunch of our lessons learned. I'm actually running out of time here, so I'm going to, again, go through this quickly. Containers don't really contain. You have to be aware of that. You know, like the way we break out of the inception-y things, we're to some degree breaking the container model, right? The container expects a certain context in place for that. You want to invest early on in making containers first-class citizens of your network stack. That's harder for people who are in companies that are 10 or 15 years old. I was lucky. Docker came out, I started using Docker, call it 2 months before I joined the company, and I wrote the first lines of code for the company for that sort. So we had an advantage that we were starting from scratch. So a little bit of luck involved there on our part. And you want to be shipping containers. Don't be thinking about, oh, I'm shipping a jar file, or I'm shipping a Go binary, or I'm shipping a commit, things like that. You want to just have the entire mindset of the only output that counts is a container. Make sense? Other things we've learned, you want to be able to overload the runtime context. We talked about this, about different config is one example. We talked about how on your local environment, you want to be able to swap out the binary from underneath the container, whether you inject it or swap it out from underneath, it almost doesn't matter. But you want to be able to do that, different configs in production and staging, things like that. You need to be able to modify the container and to be flexible, right? You want to invest early on a versioning strategy. You can tag containers, and we make strong use of Docker tagging in order to do this. We basically just use an incrementing tag. Every time a commit happens and the test pass, or every time a commit happens, it builds and tags a new container and then run tests on it. So when those tests fail, the email of shame is going to say, oh, JSON server, tag 43, failed test A, B, and C, and poor Bobby dumb coder, it has to go and figure out what went wrong, right? And of course, you're in the business of shipping containers. If you're not shipping a container, it doesn't count.
Just one more thing about the overload runtime context. So if you connect all the dots together for that sentence, right, you're only building a container once. Right? If you need some customization on top of it for your configuration files, for your environment variables, whatever it is, right? You don't change the container. You're not rebuilding it. You're just using the runtime context by the Docker volumes or whatever you have, and you have the same environment, but you are injecting this customization on top of it without changing anything, which leaves your base file system intact as it was. And operationally speaking, over time you will see that there's maintenance issues. You have less overhead of maintaining that.
Does that make sense? You only give birth to one kid and you make him wear different hats. All right. 4 kids with 4 different hats makes no sense. I don't know what I'm talking about anymore.
I mean, it's sort of like feature flag.
Basically.
Yeah.
That's basically what it is.
Just for flag.
Static builds make your life easy. We talked about this way in the beginning, and we're talking about Go binaries here. A thing that you can, just put in and just run without notion of having an OS level dependency or a runtime dependency. So in our case, Go is perfectly suited to that. Java and Python and Ruby not so much. And your base container that you choose to build your actual containers from is really important. For debug, or if you're just spinning it up, if you're just playing around, you kind of want to use big full-featured Linuxes where you can install debugging and test tools and just try stuff out really easy, like in Ubuntu or possibly even any of the big things, right? That you've heard of, CentOS or whatever. But in production, you really want to bias towards the smallest possible base container because, especially in the case of Go binaries, right? You can actually get it so that the actual shipping container is not too much bigger than your actual Go binary itself. So you can get these containers pretty small if you're talking about static builds for the most part. And that's a huge advantage because when your containers start to balloon in size, there's a big difference between a 40 megabyte container and a 300 or especially the heavier Ubuntu builds. You're going to be you're going to start at half a gig and get into a gigabyte or two if you're talking about the Java runtime, things like that. So bias towards the smallest possible base container. And again, if you're not shipping containers, it doesn't count. Miscellaneous stuff. Basically, we're out of time here, but I'll go through these as fast as possible. We're almost done. Saving time. So our bash scripts that we do write spend a lot of lines of code basically figuring out if we can skip build steps. It usually involves things like checking hash creation dates and modification dates and doing rudimentary hashing checks, things like that. It really helps with speeding up builds. You know, if it's your continuous integration system, you don't care because it's not your machine that you're waiting for. But if you're building a container locally on your machine because you just want to test it out in your local environment, you want that to be as fast as possible. So we do spend a lot of effort making our bash scripts save time. It usually involves not downloading things we don't have to and not rebuilding things we don't have to. If your downloads are up to date, we can spin up an entire cluster, again, 10 to 15 containers in tens of seconds, you know, in the neighborhood of 20 for the most part. Here's some bash fragments when I do upload the slides, which will happen in the next half hour or so. You can kind of take a look at that. But basically, this one actually checks the checksum, an MD5 checksum to see if it needs to be updated or not. It takes 3 arguments and does that. This one here is much simpler. For files that change a lot, or I'm sorry, for certain files, the wording here is completely wrong, so I apologize for the draft version of the slide. For certain files, we just check for the existence of the file. To see if we want to rebuild it or whatever. Basically, if it doesn't exist, we'll download it. If it does exist, we just say screw it. It's probably fine for files that don't change often. You're constantly pulling Git repos to get whatever the latest is because you might be working on the PDF component, but somebody in the messaging component has made updates like that. So this is just a little script to fetch all the repos in a couple of different paths, and basically just do a git pull noff on all of them. The noff is important, right? Because what it really says, if the magical automatic pull fails, then just give up, right? And the developer has the choice of doing, merge or rebase or whatever the developer wants to do. So this noff, this git pull ff only is actually really nice because that means I can basically what I normally find stuff is our script now. I think we're pulling like 30 or 40 files all at the same time. 30 or 40 repos all at the same time, and it takes like 5 to 10 seconds to do all those. If there are no changes, the pull operation is pretty quick. There's this useful command line program called Parallel. Bash, normally you can't parallelize things. You got to do them serially. But when you're talking about a whole bunch of repos, you're going to want to separate that out. So I use the Parallel program to do so. It's just something somebody wrote. You can find it. And it's actually kind of nice. It's got a little bit of a learning curve though, and a terrible UI. One thing that's helped us is to have a dummy component. This is basically a book database with a simple, dead simple model, like 3 entities and a simple REST API. This helps us test our entire stack, the messaging layer, the JSON API endpoints, things like that. It's not a full-featured REST API. If I need to test writes, I'll kind of make the new API on the fly for whatever that's worth. But this has helped us, especially in the early days when we were writing our own messaging component. So it doesn't directly. That's all I have for you guys today. Any questions? Oh, good. Making it easy on me. Go drink more food, or go drink more beer and eat more food. Yeah. All right. That's all I have for you.